And this is the operations on numpy array. Well, I think you have all known this because you guys already know Python. So, well, basically you can have addition, subtraction, multiplication. Oh, this is element-wise multiplication. So you elements multiply by elements, like, yeah. And if you do a dot product, like row times column, then you apply this function. Okay, and this function is to call the sign function to this array. And yeah, this is a transpose function. Yeah, so this is all about the arithmetics and some of the functions, like really basic functions. And here we have some logical operation to the arrays. For example, if you have an array A and you want to know which elements in this array is larger than 4, then you just place this simple logical operator to choose so that it knows what elements inside this array is larger than 4. So you click this. This is the original array. And then you select the, you select the, you check the condition whether the elements in this array is larger than 4, then it will output this array to you. So it's like, okay, the first 4 elements are not larger than 4, then it returns to false. And then these elements are larger than 4, so it returns true to you. And then there are some important application in this logical operation, because you want to maybe you want to only select some of the elements that that can satisfy certain conditions. So you may do something like here. This is a logical operation. So it basically asks if the elements of the array have a modulus of 0 if it is divided by 3. So this is a logical operator. It will return an array like this. And then if you put this array inside the A array, then it will return the elements that satisfy this condition. So let me, comment out all this thing. And if you type this, then it tells you, okay, which elements in this array satisfy this condition. So it's like 0, 3, 6. Okay. And here is some statistical operation like NP mean. Very simple, NP mean. And in NP mean, you can also define which axis to apply the mean function to. So for example, in here, this is a 2D array, right? So, okay, let me maybe make these comments. So this is a 2D array. And then if you apply this mean function, it will calculate the mean of this whole array. But if you tell him which axis to apply this mean function to, for example, here I specified the axis equals to 0. So it means I want to apply the mean function to each row of the array. So basically it will tell you, okay, yeah. So you because you apply the mean function to each row, so it calculates the mean of each column. Okay, so it's 3, 4, 5. Okay. And then here are some like minimum, you find the minimum index from the array, you find the maximum index from the array, and you find the median from the array. So these are very simple. Yeah. And this, okay, so after talking about some really simple things, here I want to show you the broadcasting rule. So broadcasting is is the way how numpy treats the different arrays when the broadcasting is basically the way that numpy treats arrays of different dimensions during arithmetic operations. So it means, okay, when there are two arrays, they are in different dimensions, and you want to add them together or subtract them together, they will do some, they will do something rearrangement to suit the final output. So for example, in here, if you have a 1D array called empty.arange3, and it is the return something like this 0, 1, 2, and then you add a 5 to this array because the two do not have the same dimension. So it will apply the broadcasting to this, and then it will extend the dimension of this constant number to 1/3 dimension array, and then add the 5 to each of the element of this array. So it becomes something like this. And here also some more examples, like this is a 3/3. Yeah, so basically it's a 2-dimensional array, and this is a 1 dimension. So it extends this 1 dimension to a 2 dimension, and then add them together. Yeah. So here are some really basic rules to do the arithmetics in numpy. Yeah, this is the examples from here. I just copied from, and then this one is, okay, a 4D array plus a 3D array. Like for example, if I have something like this, this is a 1D array, and then I reshape it to become a 4D array with the dimensions 4, 3, 2, 1, which means it has, it's complicated because it's a 4D array. Yeah, you can't imagine it. Like it's a 4D array. And then it has, like the first dimension has 4 elements, then the second dimension has 3 elements. Yeah, and the last 2 dimensions have 2 and 1 elements. And then if you multiply, if you add it to a 3D array, then it will apply the broadcasting rule. And here is the rule that it applies. So basically it's a 4D array that has dimensions 4, 3, 2, 1, and then it plus another array that has a dimension 3, 1, 5. And then if it applies the broadcasting rule, it will add 1 more dimension to here. Then the final output will become 4, 3, 2, 5. Because you add the 4 and 1, you combine them together, it is 4, right? So here you also have the same dimension, and this is like 1, so you replace it by 2, all right? So yeah, just print the shape of it because it's too large if you print the whole array. So you can see the final output of this array is by the dimension of 4, 3, 2, 5. Yeah, so this is the final output. And there are some limitations of broadcasting. So, so for example, if you do this, it will, this is the example from above. Yeah, so it just has, it's a successful broadcasting. But if you reverse the dimension of this, like first, the original one is a 2-row by 3-column array, and then it successfully applied the broadcasting because the later array becomes the dimension like this, and then it successfully applied the broadcasting. But if you change the dimension a bit, like 3/2, it cannot apply the broadcasting because the rule is not right. Because you do not have, this dimension is not matched, does not match. Basically, here numpy tells you what conditions that 2 arrays are compatible to do broadcasting. Okay, so first of all, if the dimensions are equal, they of course can do some broadcasting. But the other requirement is that one of the array has to have a dimension of 1 to apply this broadcasting. So in this case, because you don't have the same dimension here, and neither of them is 1, so it cannot do the broadcasting. So you can print this out, but you fail to do this one because the dimension is just not right. So to solve this problem, you may want to manually add some dimensions to this array so that it becomes, instead of a 1x3 array, which means 1 row by 3 columns, you make it like a 3 rows by 1 column array to make it compatible with this array to do the broadcasting. So here is one method to do this. You add a new access to the column access. So this is the row access. You just maintain all the row access and then you add a new access to be the column access. So it will become a 3x1 array in this case. Then you can apply this rule, broadcasting rule, to it. Then it will, it will successfully do the addition. Okay. Here I just add another method because I have introduced you before. You can reshape any 1D array to a 2-dimension array. So you can also reshape it to make the dimension match. So this is basically the same as this one. Okay. Okay. Here is all about the numpy operations of numpy. So